Okay, example 14 and onwards will be just discussion of selected past year questions. And we aim to complete this chapter 9A by today. Because there is still a lot much more to cover in our syllabus for the chapter of vectors. So later, example 14 until example 17, I might skip some question parts and I might leave it for you to do it on your own. And some parts that I regard as simple, I will just skip and leave it for you to practice on your own. And because we are actually rushing to complete the syllabus. Okay, so let's start with example 14. We start with part 1. Find the angle between two given vectors. This one should be easy. Okay, so angle between two given vectors. Since the vectors are already given, you don't have to identify what is a vector to use. You just use these two vectors. If your answer happen to be obtuse, you just leave it as an obtuse angle. There's nothing wrong to have an obtuse angle between two vectors. Okay. So for easier referencing, I'm going to just name these two vectors. I will let P to be 3i minus 4k, Q to be 2, 3 minus 6. And make sure to fill up this 0 here on your own because the J component has a 0 coefficient. Okay, I'm introducing the names P and Q just for easier referencing. Okay. I'm about to introduce the symbol theta as the angle between these two vectors because this angle doesn't have a name. So let's introduce a name for it. Let theta be the angle between P and Q. We have introduced P and Q, so we can just use the name. And then we have cos of theta is just 3, 0 minus 4 dot with 2, 3 minus 6 divided by the product of their lengths. Okay. Compute the dot product as usual. You have 6 plus 0 plus 24. At the bottom, you have a nice number 5 here and also another nice number 7. That gives you 6 over 7 if you press a calculator. And then just press cos inverse of 6 over 7. That gives you theta as 31.0 degrees to 1 dp. And then we are done. And since we have defined theta to be the required angle, then people will know what our theta means. And so it's good to leave. It's good enough to leave it as a final answer like this. Okay, next. Okay, for part 2, I'm going to write on the right hand side of your screen. The vector OA has magnitude, which means length. Vector OA has length of 15 and in the same direction as the vector 3i minus 4k. The vector OB has a length of 14 units in the same direction as 2i plus 3j minus 6k. Okay, so if you look at it carefully, it's actually the two same vectors as the ones involved in part 1. And so the first one is actually 3i minus 4k is actually the vector P that we named earlier. And the second vector here is actually the vector Q that we named earlier. So they say OA has a length of 15 and in the same direction as P. Okay, so the length of P, earlier we know it was 5 from our computation earlier. And so you can actually say, you can, it's possible to do this in a very quick way, because earlier we have already computed the length of vector P. And so we can say from working in 1, we have length of vector P is actually 5, length of vector Q is actually 7. Then coming to here, okay, diagram is not required. I'm drawing this diagram so that you can see what's going on. Okay, so if P has a length of 5, so what we can do is we shrink the length of P, which means you obtain P hat with a length of 1. And then because your vector OA has a magnitude of 15 units and in the same direction as P, so you just need to lengthen it. Lengthen it 15 times. Lengthen the vector P hat 15 times. So this will be a vector OA with length 15. And so if you want to go through these two steps in one go, if you want to perform these two steps in one go, it's possible. Right? So OA, it is just the vector P itself divided by its own length is 5, and then you magnify it by 15. You straight away get this one. So it's possible to do it very fast. And so what we are really doing here is that we find the unit vector. P divided by 5 is actually the unit vector of P. And then you magnify it 15 times. Okay, this is a fast way to do that. If you want to do it step by step, of course, that's no problem. If you want to do it step by step, then you can find P hat first. P hat will be P divided by the length of P. Okay, that will be 1/5 of P is 30 minus 4. And then OA is just 15 times of P hat. And that will give us 15 over 5 of 30 minus 4, which is the same as 3 times of 30 minus 4. Yeah, just erase all these diagrams. And that will give you 9, 0 minus 12, and that's it. In terms of IJK, okay, this question you can't leave it in the bracket form because they want you to give it in terms of IJK. They are forcing us to write in terms of IJK, so we have to go one line further, and this is 9I minus 12K. Okay, done. Okay, so we'll do the same thing for the vector OB. So you can find Q hat first as Q divided by length of Q. And we'll get a unit vector in the direction of Q that will be 1/7 of 2, 3 minus 6. And then to get OB, since it takes the direction of Q, you just need to magnify it. Magnify the unit vector by a factor of 14. And so it's just 14 Q hat, which is 14 times 1/7, 2, 3 minus 6, which is just 2 times of 2, 3 minus 6. That's 4, 6 minus 12. And they force us to convert to IJK, so you must do the conversion. And done. That's for part 2. Yeah, part 2 is done. And part 3 is to find the unit vector in the direction of AB. So first you need AB, which is OB minus OA. OB is 4, 6 minus 12. OA, just copy from your previous steps. Oh, there's a minus 5 as the x component. But to get unit vector, you also need the length. And this is just a length formula. You get set of 61. And then as your final answer, your subject, you write unit vector in the direction of AB. That is AB divided by its own length. It's 1 over 61 minus 560. Okay, this question, part C, they are not forcing us to write it in terms of IJK. And so it's actually okay to leave your answer in this form. Well, if you still want to convert into in terms of IJK, of course you can do that conversion. It's a simple conversion. That's minus 5 over 61I plus 6 over 61J, if you like. Okay, now let's continue with example 15. Okay, this is a question that that gives you a 3D diagram, and they want you to first form some vectors in terms of IJK based on that diagram. Okay, so make sure you know how to read a 3D diagram like this. The question will not ask you to draw a 3D diagram, but they might ask you to read a 3D diagram. So make sure you know how to read. Okay, the paragraph is long, but don't skip the paragraph. Please read it because it might give you some additional information. And whatever that is not stated in the paragraph, we cannot simply assume. Okay. Right, so paragraph says you have a semicircular prism. I believe everyone knows what prism is. Prism is a shape, it's a 3D shape where when you take the cross section is always the same surface. And so it says semicircular prism. So the cross section is a semicircle. That means AODE and BMCF, they are both semicircles. So it's useful to know this semicircle here because it would have the information that not only OA is 6 cm. Yeah, so In the second sentence, they actually say that the vertical ends AED and BFC, they are semicircles of radius 6. So not only OA is 6, you also know OD is 6. OD is 6, and OE is also 6 cm. OE is also 6 cm because it's also a radius. OE is also a radius. Okay, then they say ABCD is a rectangular base. ABCD is a rectangular base. There's also useful information because you know you have 90 degrees here, 90 degrees here, 90 degrees here, and another 90 degrees here. Okay. Okay. Yeah, that means the length of 20 cm from D to C can be brought over to AB. Okay. So it says the length of the prism is 20. So DC is 20 cm, AB is 20 cm, and at the top EPF is also 20 cm in total. Midpoint of AD is the origin O. So they are just further verifying the fact that AOD is a diameter. It says O is the midpoint of A and D, so AO and OD, of course, both are 6 cm. Midpoint of midpoint of BC is M, so you also have 6 cm and 6 cm here for BM and MC. Midpoint of DC is N. DC is one side of the base here. So DC, N is a midpoint, so that means DN and NC, they are 10 cm each. The points E and F are the highest points of the semicircular ends of the prism. Point P lies on EF such that EP is 8, then PF must be 12 because 8 plus 12 will give you 20. Unit vectors ijk are parallel to OD, OM, and OE respectively, so ijk are directions as shown in the diagram above. Okay. Now let's look at part 8. PA and PN in terms of ijk. This time they're again forcing us to give our answers in terms of ijk, so we should follow the instruction. And that means even if you do it in vertical bracket for your working, your final answer must be converted to ijk. Now looking at the diagram here, PA and PN. Okay, so where is P and A? It is this red color line here, directed from P to A. So we have to find a path, a convenient path, where every section of the path is either parallel to ij or k. It is best to find such a path to get from P to A. So one way is you can, if I erase this red line, one way is you can take the path from P to E, E to O, and O to A. And this is a convenient path. Okay, so let's write, because I don't want to scroll down, I just write my working on the right. PA is equal to PE plus EO plus OA. And then referring to your diagram, PE has a length of 8. In what direction? It is in the direction opposite to J. Opposite to J, so you have minus 8J. E to O is 6 units, but is opposite to K. So you have negative 6K. Negative 6K. Okay. Underneath your J and K, you need a curly line because J and K are unit vectors. Okay. Then from O to A, it is opposite to I, 6 cm, minus 6I. Okay. When we give answers in terms of ijk, it is preferable to arrange it in order. minus 6i minus 8j minus 6k. Arrange it in the order of ijk. And then done. If you don't rearrange, it's actually fine, but it's better to rearrange when things are given in terms of ijk. Okay. Next, find vector Pn. Okay, to get from P to N, we can also take a convenient path where every section is parallel to either ij or k. PE, EO, OD, DN. This is a convenient path. PE plus EO plus OD plus DN. Okay, PE is 8 cm, opposite to J is minus 8J. EO is 6 units downwards, opposite to K, so you have minus 6K. OD is 6 units in the direction of I, that's 6I. Dn is 10 units in the direction of J, you have plus 10J. Okay, simplify the coefficients, you have two terms that contains J, sum these two terms, and the rest you arrange it in order. You have 6I plus 2J minus 6K, and that. So here are the working for part 1 on the right of your screen. Okay, next, continue with part 2. Use scalar product to calculate angle APN. I think this should be very simple. I will just leave it for you to do on your own. Let me just tell you how to start. Angle APN already has a name. The two vectors to be considered will be PA and PN. PA and PN are diverging for sure. Right, so we have cos of angle APN is equals to PA dot PN divided by length of PA, length of PN. Okay, then you just do your computation, and you get a certain fraction at the end. Okay, then take cos inverse, you get angle APN will be equals to, final answer is 99.1 degrees, okay, to 1 dp. And this is simple, I will just leave it for you to do yourself. Okay, next, jump to example 16. You are given a trapezium such that BA is parallel to CD, and they've already drawn the parallel symbol for you on the diagram. Okay, position vectors of A, B, C relative to OA, OB, OC are all given in bracket form, which is easy to read. Okay, so that's good for us. Part 1, use scalar product or dot product to show that AB is perpendicular to BC. Okay, so you will need two vectors. Since they want to show that AB is perpendicular to BC, then naturally people would use vectors AB and BC. Okay. So let's find expressions for AB and BC. It's the usual O to end point minus O to starting point. Then find BC as well. Okay. Then take the dot product of AB and BC. So I will advise you to write AB dot BC so that people will know that you are actually dotting these two vectors. I will advise you to write AB dot BC before you sub in the numbers. I advise you to write this AB dot BC so that people will know. Right. AB.BC is this -2 -1 2 dot with 3 to 4. It is -6 -2 plus 8, and you get 0. Okay, since AB.BC is equal to 0, we can then conclude that the vector AB and the vector BC are perpendicular. And hence, the line segment AB it must be also perpendicular to the line segment BC. Okay, done. You need the right conclusion. You need the right conclusion. When dot product is 0, that means the two vectors are perpendicular, and hence the line segments involving each of the two vectors they are also perpendicular. Okay, this part here is actually optional to write. If you straight away say AB is line segment AB is perpendicular to line segment BC, is actually acceptable as well. Okay, now let's carry on with part 2. Length of CD is 12 units. Find position vector of D. Referring to the diagram above, they are telling us C to D is 12 units. Find position vector of D. Okay, we already have an expression for AB. AB is going this way, towards the left. AB is going towards the left. We already have this as -2 -1 2. Okay, so because BA and CD are parallel, then we know AB and DC, based on the diagram, AB and DC must have the same direction. It's not AB and CD, it's AB and DC. Make sure the order is correct. AB and DC must have the same direction. So once you have the length of AB, you can get the vector CD easily. Just by using the method similar to what we did in example 14. And you find the unit vector of AB, then you magnify it by a factor of 12. Then that will give you length. That will give you vector DC. You can follow a method similar to what we did in example 14. Okay. Now, the way I do this, now I'm about to show you a slightly different way of doing it. It's the same idea, but now I will use a slightly different method. Just to show you that there is an alternative. There's nothing wrong if you follow the method similar to example 14. Now, here I'm going to use the fact that okay, so first I noticed that AB and DC, vector AB and vector DC have the same direction. So AB is equal to lambda times DC, right, where lambda is a positive scalar. Okay, so not only we know that AB and DC are parallel, this equation is actually for parallel. Not only we know that it's parallel, we also know that the directions are the same. So I have more information about lambda. I know that lambda must be a positive scalar. But now I consider lengths on both sides, which means I apply modulus to both sides. Modulus here refers to length. Now, we know that modulus can be distributed over the lambda and over the DC. But then because lambda is a positive number, the modulus is redundant. Modulus of a positive number is just positive, so you can actually remove modulus from lambda. Because lambda is positive. Okay. Then we are given that the length of AB is, we don't have it yet. Okay, we don't have it yet. So let's call this equation star. Okay, now let's compute the length of AB. Earlier we have AB already, you can just refer back. That's -2 minus 1, 2. This is exactly 3 units. We continue from star. And you have 3 equals to lambda times DC. Length of DC is given as 12 units. So we have lambda equals 1/4. Okay. And now we have AB is equal to 1/4 of DC. Where I just sub lambda back into the light blue colored equation. Okay, then from this equation, you can actually try to make OD your subject already. So move 4 to the left, I have OB minus OA. Then I have OC minus OD. Oh, but wait, I think I don't need OB minus OA, since I already have AB. Okay, so I can just say 4AB is equal to OC minus OD. In making OD your subject, it will be OC minus 4AB. Okay, AB is -2 minus 1, 2. OC is this 4, 5, 6. And so we have 4 plus 8 is 12. 5 plus 4 is 9. And 6 minus 8 is -2. Okay, done. Okay, what I'm showing you here is just an alternative method of doing this question. You can of course do this question by using the fact that you can first find unit vector, the alternative. You can first find unit vector in the direction of AB as AB divided by its own length. And then the vector of DC, it will be 12 multiplied by this thing here. Just bring it down here. Then you can replace DC by, you can replace this by OC minus OD. And you just solve further. Eventually, you will still get OD as the same answer. And so this time I'm just showing you a different way of presentation. Okay, so one part in this question where many people will make mistake is that they use the different order. And so it is actually AB that is the same direction as DC. AB same direction as DC, and it's not CD. AB to the left, DC to the left. So it's actually AB and DC which are the same direction, not CD. So just be extra careful here. Daniel asks in chat, can use BA parallel to CD? Okay, it's more useful to use same direction. Same direction is more specific than parallel. Yeah, so I guess what you're trying to ask there is BA same direction as CD. Yeah, can. BA same direction as CD. Yeah, can. Because both are pointing towards the right. Yeah, can. Okay, so why do I say it's important to know same direction and not only parallel? It's because if you use the method that I'm using here, having the same direction allows me to know that the scalar coefficient of lambda must be positive. And it is because of lambda being positive that allows me to remove modulus, from my yellow circled lambda here. If I keep the modulus there, I will get two possible values for lambda. If I keep my modulus there, I will eventually get lambda equals plus minus 4, and that will lead me to two different answers. And so in this question, there's actually only one answer. So it's useful to know that the lambda must be positive. So that allows you to remove modulus from your lambda. Okay, that's example 16. Move on to example 17. Okay, I will only tell you part 1 because the rest are very straightforward. Okay, so the tricky part is actually part 1. You read through the question and maybe you can tell me in chat what's the method to show that A equals 4. And what's the method to show that A equals 4? Yes, good. Similar triangle. Yeah. Okay. So I think you have read through the paragraph. You have a square base of OABC, and DEFG is also another square, and the two squares are horizontal. Okay, the two squares are parallel to the floor in that sense. So and the trick to show that A equals to 4 is to make use of similar triangles. Let me paste my diagram over. Okay, so if you look at the triangle PDE and POA, these are actually a similar triangle. PDE and POA. One triangle is an enlargement of the other. This should be quite obvious. So these two are similar triangles. One very easy way to identify similar triangles is that when you have the interior angles, when you have the three interior angles of the two triangles, you have the same triple, meaning that you have a right angle here, a right angle here. If you name this angle as alpha, then of course the big triangle and the small triangle will share a common alpha. And if you call this beta, this must be also beta. Right? Because DE and OA are parallel. DE and OA are parallel because the two squares DFG and OABC, they are both parallel to the horizontal surface. Right? So now if I draw these two triangles separately, PDE, they will have right angle alpha beta. This bigger one, POA, is also right angle alpha beta. And so when three interior angles are the same, then these two triangles are said to be similar. Yeah, of course, a more intuitive way of looking at it is that one triangle is an enlargement of the other. And then this is also a characteristic of similar triangles. Okay. Now, for similar triangles, you can easily form equations regarding the sides. Okay, so what do we have about the sides? You have PO being 10 cm, PO 10 cm, so I'm labeling my 10 here. Okay. OD is A. If OD is A units, then PD must be 10 minus A. This part must be 10 minus A. So I'm labeling it in my separate diagram. PD is 10 minus A. OA is 10. DE is 6. Okay, the hypotenuse side is not known, but that's not important. Okay. Now, so obviously the sides PD and PO will correspond if you compare these two, and DE corresponds with OA. Okay. There are actually three fractions that you can equate when you have similar triangles. Okay, so when naming similar triangles, it is advisable to name them name the vertices following the corresponding order of the angles. So if you name your first triangle as PDE, triangle PDE, where you start from angle alpha followed by 90 degrees followed by beta, when you name the second triangle, it is advisable to follow the same order. You start from angle alpha, 90 degrees and beta, follow the same order of angles. So you have POA. So when you write the two triangles, when you name the two triangles in corresponding orders of angles, then it's easy to get three fractions that you can equate. If you take the first two letters and the first two letters, you have PD divided by PO. If you take second and third, you have DE divided by OA. This will be equal. And if you take the first and third letter, PE and PA, you will have this equality. And which pair of fractions you want to use for your computation is depending on which pair is available in the question. Okay, so we have PD and DE available, so obviously we will use the first two. We'll use this one. Okay. Yeah, these are all just draft. What's important here is your proper working that will be given mark, it will be the part that I write in black down here. All the diagrams and all I write at the top right corner, those are all just drafts, which is not compulsory. Okay, so what's important here is that you notice that triangles PDE and triangle POA are similar. So you have PD over PO is equal to DE over OA. Okay, PD is 10 minus A, PO is 10, DE is 6, OA is 10. Right. Both sides have the same denominator. We can multiply both sides by 10. 10 minus A equals 6, and easily we can show A equals 4. Sure. Okay, and done. Okay, once you have A equals 4, parts 2 and 3 will be very easy. Yeah, this is part 1. Part 1. Okay. Yeah, parts 2 and 3, I will just leave it for you to practice yourself. Okay, parts 2 and 3 are very simple. Okay. Okay, with that, I consider chapter 9A done. Yeah, for parts 2 and 3, the final answers are printed here already, so you can just easily practice yourself.